Binary adder means that it's a parallel adder. So parallel adder, why we are saying a parallel adder? So as we have taken in the last session a diagram, so which indicating four full adders, okay, four full adders, and to which we are supplying A0 B0, A1 B1, A2 B2. So actually it is meant for performing the addition operation parallelly. Why? Because so whatever A3, A2, A1, A0 or B3, B2, B1, B0, so this should be added parallelly. All these operations need to be done parallelly, but they will not be doing like that. Why? Because so this need to generate sum and as well as the carry. Based on this carry itself, it will be generating the its sum and carry out. And here this will use that carry and it will generate its sum and it will generate a carry out. So like that, one full adder, the next full adder will be dependent upon the previous full adder for its carry in. Okay, that means so for this full adder, what is the carry in? C1 is the carry in, which should come from the first full adder. Okay, and this full adder will be depending upon C2, which should come from this full adder. Okay, so it is dependent upon the previous full adders for the carry out, which is taken as the carry in for that full adder. Okay, so we need to discuss about the two topics here, that is carry generate and carry propagate. How the carry will be generated? It is based upon the inputs the carry will be generated, and that will be propagated through the gate. Here it is propagate and here it is generate. Okay, we'll discuss that. So GI is called carry generate. GI is called generate. GI is the carry generate, and it produces a carry of 1. It produces a carry of 1 when AI and BI are 1, regardless of the input carry CI. Okay, so that means so GI will be generating an output 1 when AI and BI are 1. It does not depend upon CI, so that may be 0 or that may be 1. Why? Because we are just generating. Just see here, GI is nothing but AI BI. So when you will get 1 for GI, whenever these two inputs are 1, we'll get it as 1. For all other combinations, it will be 0. It does not depend upon the carry input. Okay, next P subscript I. Pi is a carry propagate because it determines whether carry into stage I will propagate into stage I plus 1. Okay, so Pi will be representing it as AI XOR BI. AI XOR BI, and this is used for indicating that whether the carry will be propagating from this full adder to this full adder or from this full adder to this full adder. So suppose if we are just having a carry is 0, there will not be any change with respect to the carry input, or see that may not have any effect on the output. Okay, if it is 1, there may be a chance of the change in the sum. Okay, why? Because if at all you are applying 1 here, that means if you are passing a carry to the next full adder, then there can be a chance of change in the sum and the carry. Okay, this input is going to change the next carry out. Okay, so that is what the propagate is indicating. And that is based on the AI and BI inputs. Okay, so now we'll try to just write the expression for each of the case. That means C1, C2 and C3. How these will be dependent upon the carry generate and carry propagate, and after that we'll draw the carry look ahead, that is carry look ahead generator, and after that the carry look ahead adder. Okay. So after just writing these equations, you will get a better clarity of this carry generate and carry propagate. Pi is equal to Ai XR Bi, and Gi is equal to Ai into Bi. Okay. And coming to the sum. So sum is generated using this Pi XOR carry value. Just you need to make a cross verification for getting the sum. So what we are writing it as? We are writing it as Pi XOR Ci. What does that indicate? It is nothing but Ai XOR Bi XOR Ci. What is this? What is this? Is nothing but the XOR operation of all the inputs. Ci plus 1 is equal to Gi plus Pi Ci. So what is Gi? Ai Bi. And what is Pi? I think if you can remember the expressions which we derived, you will get a better clarity. It is Ai Bi plus what is this one? Ai XOR Bi into Ci. So these are the expressions. Now we'll try to see so as we know C naught is nothing but the carry input, we'll try to generate the other carries. So what is C1? What is C1? Just apply here. Just apply here. C1 is nothing but you just put I is equal to 0. So if you put I equal to 0, what you will get this expression as? G naught plus P naught C naught. Okay. So as you know G naught, what is G naught? A naught B naught plus A XOR B naught, A naught XOR B naught C naught. Okay. Just we'll not go deep into that, but just try to represent that equation. Okay. G naught plus P naught C naught. What is C2? G1 plus P1 C1. But here what is C1? What is C1? This is C1. So just try to substitute that. Okay. Whatever C1 we got in the last step, just try to substitute it here. So G naught plus P naught C naught. Okay. So that is G1 plus P1 G naught plus P1 P naught C naught. Okay. Next. So we'll also just try to write C3. So C3 is equal to G2 plus P2 C2. So but we already know P2. What is P2? Sorry, C2. We already know C2. What is that? G2 plus P2 into this expression. Just write down here. That is G1 plus P1 G naught plus P1 P naught C naught. Okay. So G2 plus P2 G1 plus P2 P1 G naught plus P2 P1 P naught C naught. Okay. And next, so that is up to C3. C4 is a carry out, so that will not be writing. So whatever the carry out from this is nothing but final carry out. Okay, this is nothing but the final carry out, so that will not be writing. Whatever intermediate carry outs, so that is C1, C2 and C3, will be writing in terms of, that is nothing but carry generate and carry propagate. Okay. So after performing this full adder, after operation of this full adder, we'll directly get the S3 and C4. So you need not propagate to another. Is it necessary to propagate? C4 to other one? No. Why? Because it is the final carry out. Okay. But here C3, it need to propagate to next full adder. What about C2? We need to propagate to this full adder, and C1 need to be propagated, so that we have returned C1, C2, C3 in terms of the carry generate and carry propagate. Okay. So now we'll be drawing the carry look ahead generator. The purpose of taking this carry look ahead generator is to reduce the delay, propagation delay. Generally there will be a propagation delay. Why? Because the carry output need to be passed to the next stage to generate the sum and its carry out. So it will take some time, and that time which is used for propagating the carry from one full adder to the other full adder, that is nothing but carry propagation. We need to reduce that delay. Okay. So that we'll be using a carry look ahead adder. So in which we have considered two parts, that is nothing but carry propagate and carry generate, that is PI and GI. Okay. So we are just writing a carry look ahead generator by using that. Okay. So coming to the C3, so what we have there? We have G2. So G2 is one input. Next P2. Next G1. Next P2, P1 and G0. Next P2, P1, P0 and C0. Okay. So this is just directly we can give. This is one adder, one AND operation. What is this? What is this? This is C3. Okay. So what do we have there for C3? We have G2 odd with P2 G1 with P2 G1. Next with P2 P1 G0 with P2 P1 G0. Next with P2 P1 P0 C0. Okay. So just we have written that expression, or just we have drawn the logic diagram for that expression. So what is C2? What is C2? So you have an expression. Just try to draw that expression. Okay. So what we have there? G1. So from this point you need to take G1. Next P1 G0. So this is P1, and here we have G0. Next P1 P0 G0. Okay. P1 P0 and C0. Okay. So this you can take an AND gate here, AND gate here is an OR gate, which is C2, and finally we require C2. Sorry, C1. So what is C1? G0 plus. So this is G0 plus P0 C0. This is P0, and here we have C0. Okay. So this is C1. So we generated the carry 1 and carry 2 and carry 3, which are nothing but intermediate carries which need to be propagated to the next stages. So we haven't written C0. Why? Because C0 is the carry in and C4 is the carry out. Okay. And this is called as the carry look ahead generator. So why we are calling it as carry look ahead generator? Why? Because so whatever the carry look ahead adder which we are taking, For that we require a generator, and that is this generator. So it is not going to take whatever all the operations which we considered earlier. Full adder using half adders. So that diagram itself you need to draw once again. Is it right? Is it right? So this is one half adder and this is another half adder, and here we can get the sum, and the carry out is obtained from the OR gate. So why we require an OR gate? It needs to take the sum of the carry out from the first half adder and the carry out from the second half adder. On adding that, that is by using an OR gate. We will be adding by using an OR gate. From that we get the carry out. So, but we will be just writing this in terms of whatever AI, BI which we discussed. This is PI, this is GI, and here it is PI XR CI, which is SI. And next, what about this one? It is PI CI plus GI, or you can write GI plus PI CI. The expression here is PI CI plus GI, which is the CI plus 1. Is it not? CI plus 1 is the carry out, so which is equivalent to GI. I think it's not clear. These expressions are self-explanatory from this diagram. Why? Because PI is nothing but, what is PI? XOR of AI, BI. And next, what is GI? GI is nothing but AI, BI and operation. Next, what is carry out? Sum. What is sum? So PI XOR CI is nothing but SI. And coming to CI plus 1, it is nothing but, so GI plus whatever GI plus PI CI. Okay. So this is the diagram and these are the expressions. And from that we have drawn the carry lookahead generator, and this is the diagram for the carry lookahead generator. So next we will go for the 4-bit adder with carry lookahead. 4-bit adder with carry lookahead. 4-bit adder with carry lookahead. So whatever all these we are just doing 4-bit itself. Okay, we are all doing with the example of 4-bit itself, so that we'll proceed with that itself. Okay. What is this logic diagram representing? Carry lookahead generator. Okay, I am drawing it as a block. So what are the inputs to them? What are the inputs to them? You require inputs called as P2, G2, P1, G1, P0, G0 as well as C0. These are the inputs required for the carry lookahead generator. Okay. And what are the outputs? C1, C2 as well as C3 are nothing but the outputs for this one. Okay. So we need to supply the whatever P1, P2, G1, P1, G1 and P0, G0 and C0 for that. Okay. So we will be drawing that like here. This is AI. So we'll proceed with whatever the notation. A3, B3. What is this one? So P3. What is this? G3. Similarly, you need to draw for the others also. That is, you need to draw for A2, B2, A2, B2, and here you will get P2, G2, and further you need to go for A1, B1, A1, B1. So here you will get P1, G1. Next, what you require finally is P0, G0 also. A0, B0, and here we get P0 as well as G0. We also need to give C0. C0 is not an output carry. C0 is an input. So that we'll be taking here C1, C2, C3 and C4, which we not included, but you need to include. Okay. So we'll write here C4, and how we will get the final output. How we will get the final output? C4 is directly C4 itself. C4 is directly C4 itself. Why? Because it's a carry out. Okay, we are not doing any manipulations with that, but we require, what are the outputs we require? We require sum. We require sum. What we are missing in this one? The sum part we are missing in this. So we need to include that part in this diagram. So carry 3, C3 I am taking here. So what are the inputs needed for this one? What are the inputs needed for S3? Just ఇక్కడ చూడండి. S3 రావాలంటే ఇక్కడ ఏమి ఎక్స్ప్రెషన్ ఉంది? S3 is equal to C3 XOR C3. Okay. We got here C3 already. So ఇంకోటి ఏం కావాలి మనకి? C3 కావాలి. Just take from this point. Take from this point and just try to include over here. Is it clear? For S3 is equal to P3 XOR C3. So C3 we got from this carry lookahead generator. So P3 which we have already generated here. So this is given as input to carry lookahead adder. But we also need to take as an input to this XOR gate. So we'll be taking from this point P3 and we'll supply to this XOR gate. So P3 XOR C3 will give you S3. Is it clear? Just we have derived from that equation itself. Next, C2 ఉంటుంది. C2 will be generated as an output. Why? Because we got here. C2 will be generated, C3 will be generated as well as C4. So C4 మనం direct గా తీసుకుంటాం. We need not do any manipulation, or we don't require for any sum generation. But we require C3 for generating sum. Okay. Next we require also C2 for generating sum. So how we will get that? Just use this equation itself. S2 is equal to P2 XOR C2. So we got C2 already, but we require C2. So just take from this point and supply it to the XOR gate. So manak P2 ikkada undi. So from this P2 just take as an input to the XOR gate, so that you will get S2. Okay. Next we have C1. So how we will get S1? So just I will draw it somewhat above. How we will get S1? S1 is equal to P1 XOR C1. So C1 we are getting from this carry lookahead generator, but we require P1, so which we need to take from this point. So space is not sufficient for me to draw here. Okay. Is it clear? So that is S1. What is the next one? C0. So C0 will be taken directly from this point. C0 is an input, C naught is an input. C naught is also directly taken here. It is not an output. It is not an output, but it can be taken directly from this block. Or else meeku ala confusion undanukunte just avoid this one. Avoid this one. Just draw here an XOR gate, and what are the inputs needed for this one? You require P naught. So I'm just unable to draw over here some point. Just give it P naught and also C naught. Okay, P naught, C naught supply chain. Okay, so that you will get S naught. Problem with the normal full adder which we considered. So there will be some propagation for carrying the carry out from one full adder to the other full adder. Okay, so we call that propagation from one full adder. We call it as a propagation delay. So the last output may not be available when you apply the input. Whatever A0, A1, A2, A3 or B0, B1, B2, B3 will be applied at the same time. But we can't see the output of S3 or C4 or S2 or S1 also. We can see only S0 output as well as C1 output. Sorry, C1 output, S1 and S0 and C1 outputs will be available. Why? Because we are giving all the three inputs, C0, A0 as well as B0. But whatever A1, B1 will be applied, but it need to get the C1 from the first full adder. Okay, so that C1 should be coming from the first full adder. So it needs to wait till it gets the C1. After getting C1, it will sum up all A1, B1 and C1. It will generate S1 and C2. Okay, so this the third half adder, third full adder need to wait for the C2. Like that, the fourth full adder has to wait for C3. So they need to wait, and it can't generate the sum also until it gets the another, that is carry from the previous stage. It needs to wait. So here what we are trying to do is we are trying to apply all the carries at the same time. We are just trying to get all the carries at the same time, and after that itself we'll be performing the addition. Okay, we are just looking for what we are looking for here. We are looking for the carries at the same time, and just we apply that carries as well as whatever the propagation, whatever P0 or P1 or P2 or P3 at the same time to get all the sums. So what are the outputs we require? We should get S0, S1, S2, S3 as well as C4. So all this we require at the same time. So are we able to see at the same time? This is first stage. This is the first stage. So all these operations will be performed at the same time. Okay, and this is the second stage. This is the second stage. In the second stage, we have the carry lookahead generator. So in the carry lookahead generator also, we have the two stages actually. This AND gate first, and next the OR gates. Okay, I haven't drawn here properly, but we have first stage as AND gates and second stage as OR gates. Okay, next, all these outputs will be available now. All these outputs will be available out of this one, and in the next stage we are applying the XOR gate. Okay, so here we have one level, and next we have the two levels over here, and after that we have the another level. So all these are applied at the same time, so that whatever all these sums as well as the carry 4 will be available at the same time. So are we getting any delay here? So we are getting some delay. Why? Because we have some additional stages. Okay, ఇక్కడ అవుతే మనకి యాక్చువల్ గా 3 stages ఉన్నాయి, కాకపోతే this related to only one full adder. సో ఈ full adder output వచ్చేసి next stage కి వెళ్ళాలి. Okay, so even though this operation may be performed, but it need to get the carry from the next stage. Okay.